Can you hear me? Yes, no? Now, okay? Yes. Guys, others? Okay, give me a minute. We'll start 6:50. Okay. Okay, got that. Before we start, today we need to discuss about what is our schedule on this. We have only very limited time. We have only very limited time, as we discussed last day. We have how many weeks? Approximately for exam, we have 24 weeks. 24 weeks. 24. Within 24 weeks, we have to 24 weeks, 24 Mondays. 24 Mondays, we have to cover all these things. We have to, I will explain what we discussed up to now in our class. This is our first lesson, area and volume. The area and volume we completed. Measuring instrument completed. This is the Pythagoras theorem. This one we need to complete. Applies knowledge on effect on forces we completed. Work energy power problem. No, work energy power we have to cover. 2. Trigonometry, okay. Rotational motion complete. Electricity we have to cover. Electricity not completed. Heat done. Thermal chemistry done. Kinetic chemistry done. Organic compounds mean biomolecules. This one biomolecules done. The investigation polymers we need to complete. Polymers not yet. Mechanical properties of matters need to complete. Fluid mechanism, both 3 lessons we have to still we not discussed. The chemical industries today, I hope to complete chemical industry, industrial chemistry lesson. The natural product last day we completed. Linear quadratic function, that means coordinate geometry, done. Descriptive statistic, everything completed with every past paper questions we discussed. Okay, these 21 to 24 lessons, ICT lessons. This 4 is ICT. This 4 ICT. ICT lesson, we not going to discuss one by one lesson. Every ICT parts we discussed within 2 to 3 days. Every ICT parts, they are very simple. In this, the first lesson is this one is operating system. This is computer system, like all level ICT. This part is very simple. Within 2 to 3 days, we complete all ICT 4 lesson. We complete. It's a very small part. Then the final one is a long lesson. That's the environmental chemistry. Environmental chemistry. Okay, now how many lessons we have to cover? How many lessons? The cell structure 1, the electricity 2, work energy power 3, work energy power, polymers. Within this month, I will complete the polymer lesson. We have 3 more weeks within this month, June. I complete the polymer complete lesson. This is a problem. 15 and 16 lesson are the problem. Others we can complete. Okay, then how many lessons? 3, 6, 7. Except ICT part, we have 7 lessons complete. Within this 24 weeks. Little bit challenge, not easy, but we have to complete. Therefore, I decide to this work energy power and the mechanical properties of matters doing by recorded classes. These 2 I will give you full recording pack of this. Tomorrow you have the work energy power. No. Fluid mechanism we need to discuss. Fluid mechanism we need to discuss the work energy power and the mechanical properties of matters. This one. This is the work energy power. This is the mechanical properties of matters. I will give you full recording pack. You can tomorrow you have live class of work energy and power. It is, I think, close to 5 hours. Tomorrow same time, 6 to 11 p.m. We discussed the work energy and power. Actually, tomorrow I'm out of Colombo, but you have to cover by our recorded classes. Recorded classes. I will schedule a live stream. The work energy power lesson tomorrow. Then after work energy power, I will give you the mechanical properties of matters. Then 2 lessons finish. Then we have the cell structures, electricity, polymers. Polymers is easy lesson. Polymer we can complete. And as large lessons, bulk lessons, we have cell structures, electricity, second, and the fluid mechanism, very important. Fluid mechanism. In this fluid mechanism lesson, we discussed the static and moving fluids. Static and moving fluid we discussed in the fluid mechanism lesson. That's also very important. The 3. That's also a bulk lesson. 4 and 5. Okay. Within this 24 weeks, we can't get 24 weeks. With minimum 12 weeks, we have to complete at least 3 months before. 3 months before mean we have 5 lessons to discuss. 5 lessons to discuss. What is this? Is June. This is June. Within this month, we can complete polymers and work energy power. Work energy power. Polymers and work energy power we can complete within this month, June. Then July, mechanical properties of matters, mechanical properties and fluid mechanism we can complete. Fluid mechanism. This is within July. And if there are any possibility, if we can complete part of environmental chemistry or cell structure, that's a bonus. That's a bonus. If we can try, we'll try. Then if we complete, we have to get additional extra classes. We have to get extra classes. Okay, then the 4 lessons complete. Then August. Within August month, we have to complete which? Within August, which one is missing? Within August, we have to complete cell structures and environmental chemistry 2 lessons. Cell structure and environmental chemistry. Okay, that's all. Within August month, the entire syllabus is complete. Full syllabus ivarai. Then after that, after August, we have September and October. We have 8 weeks. The exam is November. Then within these 8 weeks, we come both Monday and Tuesday, both the entire, we have 12 hours. 12 hours we discuss papers. We have a special program on this final 2 months. Before that, we discussed only we can get for theory lessons, only we can get 1 day. If it is Monday or Tuesday, the second day we have to get for paper discussions. We have to continue this paper discussion series, and you have exams in each month. You have exam when it is complete. For your this exam, this month exam is next week. Okay, next week you have exam. For this exam, industrial chemistry and natural products, both lessons coming for this exam. Environmental chemistry. Additional previous lesson, industrial chemistry and natural products coming for this one. Okay. Okay, any doubt about any lesson? You can ask. Any doubt? Okay, go to the tute. Just I explain our plan. Don't think about that. I just explained because it is not easy task for me. We have 6 lessons. The all 6 lessons are very bulk lesson, long lessons. Environmental chemistry, cell structures, only work, energy, power, and mechanical properties of matters. Small lessons. They are within 2 to 3 days. Actually, better to complete them by videos, recorded classes. Then we can easily complete the cell structures, polymers, and other parts. Environmental chemistry and yeah, you can skip. Yeah, same class you came for, same 26 students class stream tomorrow. But you can skip and you have to work. Okay? I will give you another work for you. Okay, get the tute to start the lesson. Get the tute. Environment में क्या बनने? Industrial chemistry. Okay, we discussed up to the basic part we completed, no? The basic part we completed. Okay. Sorry, today. Okay, so 7 p.m. Okay, let's start. Okay, what we discussed last day? We discussed. Now, do you remember what is a chemical industry? What is a chemical industry? A chemical industry, do you remember? The definition of a chemical industry? The definition of the chemical industry, do you remember? Okay, send me the definition of what is a chemical manufacturing industry. What is a chemical manufacturing industry? The definition I need. Mahima, I remember the definition of the chemical manufacturing industry. In the tute, the perfect definition, the complete definition I given in the final last day. Chemical manufacturing industry. Yeah, I told in chemical manufacturing industry, compulsory the chemical conversion, no? Chemical conversion, that means reactant, whatever reactant convert into product, convert into different product. As we discussed in kinetic chemistry, the product features totally different from the reactant features. Their characteristics are totally different. That is products. using energy produced by chemical conversion. Okay, that's a summary of the chemical manufacturing industry. So whatever useful reactant being raw material convert into whatever useful product by chemical conversion using energy and power mean totally energy. Using energy, whatever raw material convert into useful product by chemical conversion. This process doing large scale the production process we called as a chemical manufacturing industry. In your word, you can prepare answer in the tut I have given. No? Last day also I given the full definition of chemical manufacturing industry. It should contain in your definition the chemical conversion the word should have and the large scale process. Normally the chemical industry is very difficult to start in small scale because their initial cost and environmental effect, they are very small and medium scale, very difficult to maintain a chemical industry. Not like as other industry, the chemical industry very small, in small and medium scale, very difficult to maintain. It should be a large scale process. If it is chemical industry, it must be large scale because they are maintaining cost, initial cost. Because of that, it is very difficult to maintain in small and medium scale. The chemical manufacturing process always a large scale process. Useful raw material convert into useful product by a chemical conversion using energy. That's a chemical manufacturing industry. Okay. Okay, today we're going to discuss about different types of chemical manufacturing industries. Different types of chemical manufacturing industry. Industries that use chemical energy to produce product by chemical conversion. It's a large scale. Okay, very good. Okay, now today in this lesson, we mainly discussed about Sri Lankan possible chemical industries. When we consider about the world condition, there are different types of there are more than 100, actually more than 1,000 types of chemical industries we can found. But in this lesson, we mainly discussed about Sri Lankan most possible chemical industries. Most possible chemical industries in Sri Lanka. Remember, the first one is soap production. In this lesson, today we're going to discuss first about soap production. The second one is biodiesel production. The third one is paint production. Every raw materials, byproducts, the chemical conversions, how using these chemical raw materials, how the soap, the final product is produced, everything we discussed in the today lesson. Okay, paint production. After that, today we're going to discuss about fertilizer production. Fertilizer part we have discussed, very important, very interesting part under fertilizer production. After that, we're going to discuss about the paper production. Okay, that's the full summary of the lesson from this point to final point. If we complete these all industries, the industrial chemistry is complete. Industrial chemistry is complete if we complete these all industries. All industries. Okay. Go to the first industry. As I told that these five not මේ පහ විතරක් නෙවෙයි ලෝකේ තියෙන්නේ. හරිද? There are different types of chemical industries in the world, but in this lesson we discussed about most possible chemical industries in Sri Lanka. In Sri Lankan condition, most possible chemical industries. Okay. First of all, we going to discuss about soap production. First one is soap production. Soap production. Okay. Normally, what do you think? What are the main raw material according to your general knowledge? What are the main raw materials for soap production? Soap production. What are the main raw material? What do you think? What are the main raw material for soap production? What do you think? කොහොමද සබන් හදනවා ඇත්තේ? No, Teva. Okay. What your ideas? I just want to check. Yeah. One is caustic soda. One raw material is caustic soda. Good. Caustic soda mean, remember, sodium hydroxide is caustic soda. It is caustic soda. Sodium chloride mean, sodium chloride is our salt. Sodium chloride is salt. You see your answers? Very good. Amar, yeah, vegetable oil correct, but try අදීශලගේ ඔබල් වැඩක් නෑ. අදීශලට මම කරලා තියෙනවනේ. අමර් vegetable oil or whatever oil. Okay, whatever oil we need, they are the main raw materials. Makeup අයින් කරන්න පුළුවන්. We can discuss about salt later, sodium chloride later. Main raw material, that is caustic soda. Sodium hydroxide is a caustic soda. This is a powerful base. It's a powerful base. And we use triglyceride. The main raw material is triglyceride. It can be whatever type of oil. Whatever oil contain triglyceride. You know, every oil fat, then we can use oil or fat. Not only vegetable oil, it can be vegetable oil. It is possible we can use animal oil as well, because triglyceride we need. The main raw materials are triglyceride and sodium hydroxide, caustic soda. They are the main raw material for soap production. Okay, today I will explain how to produce a soap sample in your home. You can try. I will show you every practical videos, and I will explain how to prepare a soap sample in your home at the end of the soap discussion. And after discussion of biodiesel, I will explain in your school laboratory how you can prepare a sample of biodiesel. Okay, in paper production is difficult in your home condition. Sorry, battery low. Give me a second. Okay, sorry. You can try soap sample and biodiesel sample. You can try biodiesel in home condition. You can, yeah, it needs some specific equipments, but soap you can try in your home, but carefully you need to try. Okay, I will explain how you can. Actually, you can. The sodium hydroxide is very low. That's a very low cost material. The sodium hydroxide in your hardwares, you can ask sodium hydroxide. It is like you can get 100 gram like 50 rupees, very low, cheap. Then you can buy sodium hydroxide caustic soda. Then you can try. You need only whatever coconut oil or whatever oil type contain triglyceride and caustic soda. Okay. Okay. The main raw materials are sodium hydroxide and triglyceride. Whatever triglyceride with caustic soda. Now, how you this sodium hydroxide, when we react this sodium hydroxide, it is caustic soda plus triglyceride, caustic soda and triglyceride. Then the product, when we mix in this mixture, the specific product is produced that we called as sodium stearate. Remember, I will explain later. Now I am going to discuss the basic of soap production. Then we can, in advanced in depth, we can discuss in chemical names, chemical structures. We can discuss how this soap is produced. Okay, now in basic understand, the caustic soda is sodium hydroxide, then react with whatever triglyceride, that is animal or plant oil, then sodium stearate is produced, then another product is produced that we called as glycerol or glycerine කියලා කියන glycerol. Okay, that is the basic of the soap production. This sodium stearate we called as the soap. Then what is this glycerin? This is the product. The soap, this is the product. Okay, this is the product, sodium stearate. This is our target. Then the glycerol is, what is this? This is the byproduct. When we produce soap, as byproduct, the glycerol is producing. Okay, we can't avoid this production. That's a reaction as one product. The glycerol is producing, that we can't stop this. That's auto when we in this as result of this reaction, the glycerol is producing. Then glycerol is a secondary product, that is a byproduct. That's a byproduct. This is the product. And do you know? Okay, now the basic I think you got. I will explain about glycerol later. What is the main raw materials? What's the main raw material? Caustic soda and triglyceride. When we react caustic soda and triglyceride, sodium stearate and glycerol is produced. This sodium stearate is the soap. This is our product. This glycerol is the byproduct. That's a secondary product while doing this reaction. I got the basic. This part is very important. Therefore, try to remember everything with my explanation. Otherwise, if you read anything in the internet, oh, very difficult to, there are a lot of information. If you search soap production, you can find many articles, but you can't remember everything. You can read and get some idea, but you need to remember my explanation area. Okay, I got all the basic. I got. Please reply. Otherwise, today lesson is we have to go with as a discussion. Otherwise, it will difficult. Siobhan? Okay. Now, caustic soda and triglyceride is a raw material. The sodium stearate is the main product. Glycerol is produced as byproduct. This chemical reaction has a specific name. Remember the name. This chemical reaction we called as saponification. This chemical reaction we called as saponification. Oh, problem. This chemical reaction we called as saponification. Saponification. This chemical reaction we called as saponification. Okay, then what is the saponification mean? The main chemical reaction in the soap production, the main caustic soda and triglyceride react each other, then produce sodium stearate and the glycerol as the product sodium stearate and byproduct glycerol. The production process that we called as saponification. That saponification is the main chemical reaction in soap production. The name of saponification is the main chemical reaction in soap production. Remember, when we discuss biodiesel, they will very important, because biodiesel chemical reaction also there is a name that's called as trans-esterification. Okay, don't think about that. Still, you only need to think about soap production. Soap production main chemical reaction is saponification. 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 Okay, go to the tute. Go to the tute. Go to the tute. The soap, the first part I will explain later. Go to the second one, second paragraph. The main ingredients used in production of soap, caustic soda and vegetable or animal oil containing major consist of triglyceride. Containing anything triglyceride. In the production of soap, the ester bonds are broken. I will explain what's the reason, meaning of that. By the reaction between this triglyceride molecule and sodium hydroxide and formation of sodium salts of fatty acid. That is a sodium stearate. The sodium salt of fatty acid. I will explain now why we call sodium stearate as sodium salt of fatty acid. That's a specific name. Sodium salt of fatty acid. That's a sodium stearate. That's a soap. And glycerol is produced. Glycerol is a byproduct. The soap production reaction called as a saponification. Saponification. Okay, so production reaction we called as saponification. Remember this name. Okay, now we try to move into the saponification reaction. Come to the saponification reaction. Saponification reaction. Saponification reaction. Okay, in saponification reaction, the main ingredients are triglyceride and sodium. Main raw materials are triglyceride and caustic soda. The triglyceride structure, do we remember? The structures of triglyceride? Triglyceride, do I need to explain how to produce triglyceride? Do you remember? Can you explain triglyceride structure? What are the building blocks of triglyceride? Triglyceride, what are the building blocks? That's a biomolecule lesson. What are the building blocks of triglyceride? What are the building blocks of triglyceride? Quickly. No. Building blocks mean the not compound molecule. Teva. Molecule, carbon, hydrogen, oxygen, correct. But I asked, what are the smallest compound, not molecule? As example, in polysaccharide, in carbohydrate, the smallest compound, the building blocks are monosaccharide. In proteins, the building block or smallest compounds are amino acids. In lipids, what are the main building blocks? Yeah, fatty acid and glycerol. Very good. Fatty acid and glycerol. Adishat everything him. Fatty acid and glycerol. Fatty acid and glycerol. I think you remember. I think the biomolecule. Remember what is the structure of triglyceride? Do I need to explain again? Structure of the structure of triglyceride. This is the triglyceride. The main building blocks are glycerol and fatty acid. In triglyceride, the triglyceride mean one glycerol and three fatty acid. One glycerol and three fatty acid. The glycerol structure is that CH2OH, CHOH, CH2OH. This is glycerol. This is glycerol. Then the fatty acid structure is RCOOH, RCOOH, RCOOH. This is two fatty acid. The third fatty acid also RCOOH, RCOOH. Then these two OH groups combine together. Then three water molecules removing. Three water molecules removing. Then which bond is formed between glycerol and fatty acid? What's the bond between glycerol and fatty acid? What's the bond formed between glycerol and fatty acid? What's the bond? Quickly. This. What's the bond formed between glycerol and fatty acid? Ester bond. Very good. Can't you put your message answers into main chat? Main chat main chat private. In my one, main chat and private chat, it's coming as a separate. Can't you put into main chat? Otherwise, I have to go one by one, and because of this Zoom new update, I have to go one by one and check. within ඒකට දාන්න main chat එකට දාන්න. හැමෝම S කියලා දාන්න බලන්න main chat එකට. Yes. ඒකට දාන්න. එතකොට පේනවා. Okay. Okay, this is one glycerol and 3 fatty acid. Then I told this 2OH, 2OH, 2OH combined together. Then 3 water molecules are removing. Then 3 water molecules removing and 3 ester bond form between 1 glycerol and 3 fatty acid. Then produce triglyceride like this. Triglyceride structure CH2, 2OH, 2OH, H2O removing, then only oxygen is remain. Only oxygen is remain. Only oxygen is remain. Only oxygen remain. Then others are same. Others are same. This is the ester bond. This is the ester bond. Then next one, CH, oxygen remain. CH2, oxygen remain. COO. This is a triglyceride. I think in biomolecule lesson, again, now I'm not going to discuss more than this level. You got the, this is the structure of triglyceride. The structure of triglyceride, 1 glycerol and 3 fatty acid combine each other, then forming 3 ester bonds and removing 3 water molecules form triglyceride structure. This is the triglyceride structure. Then triglyceride structure, and what is the second raw material? The sodium hydroxide react each other. This is the saponification. Okay, what's the name? Saponification. That's a soap production reaction. Soap production reaction. I will remove this part now. This don't need. Okay, this is the triglyceride. I will write. This is the main raw materials. Triglyceride, triglycerides, and caustic soda. Don't need to write. You already know the caustic soda. Triglyceride and caustic soda. Then triglyceride and caustic soda. Okay, then what is produced? The sodium stearate is need to produce sodium stearate and glycerol. Okay, before we go to the sodium stearate, understand this. In this reaction, I have given in the tube, these ester bonds are breakdown. These ester bonds are, understand this part very well, then others very simple. These ester bonds are breakdown, and this CH2 react with OH. Ester bonds are breakdown, and the sodium hydroxide also break down into sodium plus ions and OH minus ions. OH minus ions. Then CH2 ion, CH2 compound react with this OH. Then other parts combined with the sodium. Other part combined with the sodium. Understand this part very well. If you not understood, ask me again. This is the most important part. If you can't understood, this part is very difficult, because that's in chemistry, that's the most important part. Every difficult part we already discussed very simply. The thermal chemistry, kinetic chemistry, every calculation we done very simple way. Then that's also understand very well. Then the sodium is remained. The sodium plus ion combined with this sodium plus ion sodium plus ions combined with here, with connected. Then you can, this is the sodium oxygen වෙනසක් නැහැ. That is the soap. Sodium connect with the fatty acid. That's why I call this is the sodium stearate. There is another name for that sodium stearate I have given in the tube. For another name, sodium salt of fatty acid. I got sodium salt of fatty acid. That's why we call sodium. That's a fatty acid connect with sodium. That's a soap. I got, that's a soap. Finally, as byproduct, this OH group and CH2 combine together, then produce CH2OH. Then again there are another another CH. It also contact with OH. There is another CH2 connect with OH. Then what is this? CH2OH, CH2OH. What is this? What is this structure, final structure? What's the name? Quickly. Now, today we have a huge work today. What's the name? CH2. If you want, I will draw here CH2OH, CHOH, CH2OH. What is this? Yes. This is the glycerol we discussed in the triglyceride formation as the main building blocks. The glycerol. This is the glycerol. Then the byproduct is glycerol. Have you got any doubt? It is exactly, it is an exam question this time. Write down the saponification reaction. Exam question is in the structured essay or essay part. Write down the saponification chemical reaction. This is the chemical reaction. I got. Then what is the sodium? What is the sodium stearate? What is the sodium stearate? Sodium salt of fatty acid. Any doubt? Quickly ask if you have any doubt. Any doubt? Are you good? Yes or no? Quickly. Okay, I have given space in the tube. If you don't have tube, today I posted your tubes. Then tomorrow is holiday. It will, within 2 days it will come. Okay, if you don't have tube, write down them with page number in separate paper. Then after that you can complete. When you receive your tubes, you can complete it. Okay, note down this space. You have to note down. I told you have to put page numbers because the page numbers missing in this tube. 1, 2, 3, 4, 5, 6. Yeah, page number 6. This space. Okay, write down this. That's a saponification reaction. If you want, you can write the topic as saponification reaction. The topic is saponification reaction. The saponification. In the tute also I have given in the above paragraph, this is the saponification reaction. Saponification reaction. Remember very well, this is the name of chemical reaction in the soap production. Saponification. 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 Complete. Triglyceride, sodium hydroxide, then sodium connect with this part, then sodium stearate, that means sodium salt of fatty acid is produced. Finally, CH2 connect with OH groups, CH2OH, CHOH, CH2OH, glycerol is produced. Okay, if we balance this chemical equation, you know, every chemical equation need to be balanced, no? Therefore, if you balance this chemical equation, it need to come 3 and 3 soap molecule. Remember that one triglyceride molecule, we can produce 3 soap molecules. We can produce 3 soap molecules. When we balancing, it should be 3. So, because it is, yeah, it should be 3 because this side sodium 3. Therefore, this side also need to be 3 sodium molecules. Okay, that's the full chemical equation of the saponification. Full chemical equation of the saponification. Okay, now that is in chemical. You know, now I will explain very simply and in practical way how we produce a soap. How we produce soap. Okay. Understand, if you understood this process practically, anything don't need to remember in this part. Okay, that's a entire all production process like one practical you can remember. Okay, each production process as one practical you can remember. Then anything don't need to remember. Find whatever thing in anywhere. You can remember. If you can remember this practical, that enough. Okay, I'm going to explain how to produce soap. How to produce soap. Okay, first of all, our raw materials we need to prepare. First of all, I need to get normally, as I explained, this soap production or whatever production process doing in a reaction chamber. No, I remember the features of reaction chamber I explained last day. The features of reaction chamber, the heating pan, mixture method with stir motor, and raw material input valves, product output valve, byproduct output valve, and temperature measuring unit, the pressure measuring gauges, the pressure meters. Yeah, there are different types of features include the all chemical reaction. Even in soap production, it's doing in a specific reaction chamber. But I'm going to explain in simply in laboratory level. If we want to produce soap sample, how we produce, then you can imagine in industrial level the same thing. In industrial level, every reactions happening in a chemical reaction chamber. Then very difficult to understand that level, the process of production. Therefore, I will very simple level, I will explain how to produce soap. Then you can imagine what happened in industrial, large scale industries. Okay. First of all, think this is I will use a very simple reaction chamber like a beaker. But in industrially, that's not the reaction chamber. It's a specifically produced large scale reaction chamber used for production process. Okay, don't misunderstand. Okay, first of all, I need to get some amount of triglyceride, that means whatever oil, triglyceride. Then I need to heat this. Okay, very simple. Just heating. When it is heating, do you have seen caustic soda? 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 Yes or no? Do you have seen caustic soda? Caustic soda just like salt crystals. It's just like salt crystals. They are like crystals. In hardwares, you can buy caustic soda crystals like this. After dissolved in water, we can prepare a solution. They are dissolved in water, then we can prepare base solution. The sodium, they are solution. They are the crystals. In hardwares, we can buy these sodium hydroxide crystals, caustic soda crystals. This is caustic soda. This is the structure, sodium and hydroxide, the chemical in structure. Okay, normally I just want to show you, this is the structure of caustic soda. They are crystals. Okay, then if you dissolve in water, we can prepare aqueous solution. Caustic soda, aqueous solution. Now I need to get some amount of required amount of caustic soda, and we need to dissolve 50% we need to dissolve in water and prepare 50% solution. 50% mean water 50%, the caustic soda 50%, like this. Okay, 50%. As example, 1 kilogram of caustic soda, 1 liter of water. Normally 1 liter of water equal to 1 kilogram approximately. Not accurate. If pure water, it's correct, but with minerals it can be changed. If we got approximately 1 kilogram of caustic soda with 1 liter, 50% caustic soda solution. Caustic soda, sodium hydroxide, aqueous solution. I think now you can understand what's the meaning of aqueous. We already discussed. Caustic soda, sodium hydroxide, aqueous solution. 50% aqueous solution, 50% with water and caustic soda. Okay, 50% caustic soda we need to prepare. After that, we need to add this caustic soda when the oil is heating. When the oil is heating, this 50% caustic soda solution we need to add to the triglyceride mixture, oil mixture. The very important thing is when we adding and after adding, the solution must be mixing, must be stir very well. Otherwise, the soap production is not become uniform. To keep the uniformity of this production, we need to stir. We need to mix this mixture very well to keep the uniformity, the standard of the product, final product. Okay, the mixing is very important because it is a very heated system. When we add sodium hydroxide to react this, the triglyceride molecule, and I think you remember in kinetic chemistry, triglyceride molecule and the sodium hydroxide molecule need to be, the molecules need to be coincide, collide, no, not coincide, collide, need to be collide each other, and they are already available bonds are break down, and that means ester bonds break down, sodium hydroxide, sodium ions and OH ions break down, then they are need to produce new bonds. Okay, therefore the mixing is very important for this collisions. For collisions, this mixing is very important for to get uniform production, uniform final product, standard final product. The mixing is very important. Okay, now I'm mixing with very well. When I'm mixing the mixture, when I'm mixing the sodium hydroxide and triglyceride mixture, I can feel the mixture become little bit thick. Increase the thickness of this mixture. Increase the thickness of this mixture. After 20 to 30 minutes, I can decide that is the thickness increase because of sodium stearate is produced. Sodium stearate is produced, then I can decide the reaction is completed now. The reaction is completed mean sodium hydroxide and triglyceride molecules react each other. The sodium stearate and glycerol is produced. Okay, that's a saponification, no? That's a saponification. The saponification is completed. When the saponification is completed, the solution become increase the thickness of this solution. Increase the thickness. Okay, increase the thickness. If there are any doubt, send me. Okay, now after that, now think this is the after mixing 30 minutes, approximately 30 minutes. This is the final mixture. This is the final mixture. Okay, now tell me what are the compounds available? What are the what is contained in this final solution? Yeah, it contains soap. It contains soap now. Sodium stearate. Soaps. Then glycerol. 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 What other things contained in this solution? Other compounds? What do you think? Very good. Others, what do you think? Make it through it. Yeah, soaps. That means sodium stearate present, and glycerol is present because that is byproducts. Then other than these compounds, other than these products, main product and byproducts, what is produced, what is remain here? Very good, Chevon. You know, in this in the kinetic chemistry lesson, we discussed when we react to reactants, these both reactants not reaction completely. Some part can be remain. I remember when we discussed in calculation. Do you remember we discussed about excess amount of sodium hydroxide, excess amount of HCl we added, then it is exactly remain. The excess amount will remain. The only limited one is finished. Therefore, this one, the unreacted sodium hydroxide, caustic soda can be present. Unreacted caustic soda, sodium hydroxide also there. And some part of triglyceride also can be present. Triglyceride, it is very limited. Triglyceride only little bit, because if there are any triglyceride, remain sodium hydroxide and triglyceride react each other. Normally, probably the only sodium hydroxide, the triglyceride can be finished, because if there are any remain triglyceride, it is react with sodium hydroxide again, it can convert into soap or glycerol. Therefore, they are the main products remain in the final mixture. I got? Send me quickly. Yes or no? Quickly send me, then we can go to the next step. Okay, soaps present, glycerol and unreacted sodium hydroxide can be present. Right? Okay, now remember very well, after this solution, after we got this solution, we need to add sodium chloride solution. Sodium chloride solution. It is sodium chloride solution. Sodium chloride means not sodium hydroxide. Okay. Sodium chloride means normal salts. Sodium chloride solution, we need to add into this final solution. Then what happened? This sodium hydroxide is a mineral, that's a salt. Then what happened? The sodium chloride solution, the sodium chloride solution means sodium chloride aqueous solution. Aqueous solution is water and sodium chloride. This water and sodium chloride not mixed with soap. The soap is, I will explain. Normally, soap is a non-polar and polar mixture. Therefore, this whatever water or sodium chloride not dissolve in soap, they dissolve in glycerol. And after we mixing with sodium chloride, we need to transfer this mixture into separation funnel. It can be Buckner funnel or whatever separation funnel. In separation funnel, normally if we not adding any sodium chloride, the glycerol is higher density than soap. Remember, more than sodium stearate, that's a thick solution. In this thick solution, the glycerol is normally higher density, greater density than soap. Soap is low density. Therefore, always soap is dissolved on the glycerol. Sorry. The soap is floating on the glycerol. Think when we add this solution into this separation funnel, Normally this layer is glycerol because glycerol has higher density than soap, sodium stearate. This is the soap layer. Remember the soap layer. This is soap layer. This is a normally the glycerol has higher density than soap, glycerol. But when we add in the sodium chloride solution, the density of the glycerol is increased more than normal level. The density is increasing. Therefore, what happened? The glycerol layer and soap layer clearly we can see because of adding the sodium chloride. The density of the glycerol is increasing. Therefore, glycerol layer and soap layers, sodium stearate, this yellow color thick layer, separate very clearly as two layers. Then using this separate funnel, if you want, we can centrifugate. Centrifugate means we can rotate the centrifuge. Then the two layers are clearly we can observe this is the below layer is glycerol and above on this glycerol the soap is floating. Then using these separating funnels, we can separate this glycerol and we can remain only soap layer. We can remain only soap layer. Okay, the soap layer we can get separated by soap layer. Okay, after that the separated glycerol, separated glycerol. Think this is the separated glycerol. This is the separated glycerol. Again, we add sodium chloride. Again, we add sodium chloride aqueous solution, and again we go through this separating funnel. If there are any remain soap part, we have to collect that also because otherwise economical damage. No? Therefore, we have to again only one time we can again add sodium chloride, and if there are any remain soap, we can separate this separated glycerol also. Then after that, this glycerol is what we do for this glycerol. After separate, it is a waste. It is a waste for what's the purpose of this glycerol? Glycerine kilatken. What's the purpose? Do you know the purpose of the glycerine? The purpose of the glycerine? Body apply. Glycerine directly we can't use for body apply. But glycerine used for different cosmetic industries. Different cosmetic industries and mainly toothpaste production. Toothpaste productions, mainly we use glycerol. The glycerol is a main raw material for toothpaste production. Therefore, we can sell this glycerol. The glycerol is byproduct in soap production. We can get economical value by selling this glycerol as well. You know, we can get some income. Okay, now after second separation, the removing sodium hydroxide caustic soda, we remove for whatever cosmetic production or toothpaste production, we can sell this. Okay, we can sell this, the removing sodium hydroxide caustic soda. Okay, now the separated soap, the separated part of this second step, again we add to this funnel. Again we can add to this funnel and again centrifugate, and if there are any glycerol remain, we can remove again. Finally, somehow we have to separate the thick sodium stearate layer. Thick sodium stearate, that's a yellow color layer. Yellow color layer. Are you got up to now? Up to now, I will give you summary of that again. Up to now, summary. Any doubt up to now? Any doubt up to now? Okay, first of all, what you need to do? Get a triglyceride solution and prepare 50% of caustic soda solution. We add when the triglyceride is heating, caustic soda add and mixing well to get uniform product. Finally, the after 30 to 20 to 30 minutes, we can get a thick solution. It is contains soap, glycerol, and sodium hydroxide, unreacted sodium hydroxide, caustic soda. Then we need to add sodium chloride aqueous solution, dissolve in water to and mix it well. Mix it well. Then sodium chloride dissolve in this glycerol. Sodium chloride dissolve in the glycerol and increase the density of this glycerol. When we separate after the separating funnel, when we centrifugation, we can get separate layers, soap and glycerol very clearly when we add sodium chloride. That's the purpose. Okay, after that, the glycerol is separating and sodium stearate we can get as upper layer. If there any remain sodium, if there any remain soap parts in the removing sodium hydroxide, again we can add salt and we can again separate and get to the final product. Up to now, okay? Send me yes or no. Okay, after that, this yellow color thick solution, yellow color thick sodium stearate solution, yellow color thick sodium stearate solution. What are the compounds contained? It is don't have now. If I got separate this, I will go to a new page. If I got separate for this thick colors, thick yellow color solution, what are the compounds contained? Now it contains sodium stearate, soap, sodium stearate. What other? Now previous on the solution only only glycerol we remove. Then soaps and sodium hydroxide, unreacted caustic soda still there. Still there in the solution. Remember? Okay, now it is so unreacted sodium hydroxide still remain. Unreacted sodium hydroxide still remain. Unreacted sodium hydroxide still remain. Now remember that. Now what you think about the pH level of this this thick solution? What do you think about the pH level? What do you think about the pH level of this final solution? After glycerol is removed, the final solution, what do you think about the pH value? It is very high. Huh? Chevron, how it is acidic? The sodium hydroxide is a powerful base. It is highly base because basic because normally the pH value is near 7 to 8 because it has unreacted sodium hydroxide. Therefore, if we apply the with this level, yes, basic with this in the same condition, if we apply on our skin, it can burn our skin because you know if any very acidic like 100% HCl acid, if anything contact in our skin, it is burning. Samely, if it is higher pH value, any material contact with our skin, it's also burning. Therefore, it is very dangerous, very harmful for our skin. Therefore, now we need to get the soap pH value into favorable safety level. Then we have to add sorry, we have to add citric acid. We have to add citric acid for this solution, final separated solution, to get the pH value into the favorable condition, favorable level. Normally the neutral condition is good. The neutral condition, sorry, not 7 to 8. 7 to 8 is favorable condition. The normally the pH level is 13 to 14. 30 to 14 level, when it is separated this solution, the 13 to 14 mean highly base. Then we need to add citric acid to get this pH into favorable pH value. Favorable pH is normally 7 to 8. Normally we not going to, less than 7 is not required. The soap is normally base is okay, but it should be in a favorable range. If it is highly base, it is damage to our skin. Then therefore we can add any type of acid, because but we add citric acid because it is low cost. Normally if we add hydrochloric HCl, sulfuric like acid, it's also okay, but they are very expensive acids. The citric acid little bit cheap, therefore we can add citric acid to get the, remember this each point. Why we not going to add hydrochloric sulfuric acid? We can add, but because of they are expensive, we not going to add normally, because only we need to get the pH into favorable range. Therefore we can add any cheap acid. Okay, after that now the sodium hydroxide, unreacted sodium hydroxide, we can neutralize by adding citric acid. Therefore unreacted sodium hydroxide problem is so solved. Unreacted sodium hydroxide. Now our final product is ready. The soap, sodium stearate, yellow color thick solution is ready. Now what I need to do? What's the final step? The final step is we have to add very important filling materials. This is the very important part of the production process. Filling materials. Do you know, when we produce soap with 1 liter of triglyceride, 1 liter of coconut oil, the amount of soap produced is very low amount. Amar, how about how quantity you produce by 1 liter of coconut oil in your school? 200 to 300 gram approximate. Yeah, think 1 liter, think only 200 gram of soap. Think, how about the price of 1 liter of soap? 1 liter of soap, think, now I don't know oil price. Think it is approximately 1 liter near to 1000, no? Think it is 1000? Oil and other all production cost is 1000. Oil and other all production cost is 1000. Then only we can get 200 gram soap. The 200 gram mean 2 bars. No? Normally 100, approximate 100 in one soap. Then only 2. Then what is the price of one soap? Only production cost. Only production cost 500. With all profits, it's close to 700. One soap. One soap bar, it is 700. Is it possible? Is it very difficult? Therefore, we have to add filling materials. We have to add filling materials. In Sri Lankan condition, normally we add soap. Normally we add sands as filling materials. If you go to Vim එකක් අරගෙන, if you observe the surface, you can find fine salt, not salt, sand compound. Sand crystals you can find. They are the filling materials. Not only Vim, every soap type we add soap. We add filling materials, sand. But the thing is, the smooth soap, baby soap, like smooth soap, when we produce, the smoothness is depend on the diameter, thickness of this sand. If it is the grind into very crystals, very smooth crystals, very tiny crystals, these soaps are smooth soaps. If it is the diameter of the crystals are high, they are rough soaps. Rough soaps. Okay, that's how depend the roughness or smoothness of the soap is depend according to the filling material. Therefore, the filling materials, remember, sands we can use, sands, or we can use calcium carbonate, that's me, calcium carbonate, sodium carbonate we can use, but in Sri Lankan condition, normally we use sands. Sand means silicon SiO2. SiO2 main compound is, main molecule is silica. Silica sand. Silica sand we use for as filling materials. By grinding, the grinding diameter is depend the smoothness of the soap. Smoothness of the soap. Okay, after at filling materials, we can increase the quantity of this solution. We can increase the quantity of this solution. After that, we have to add different coloring agents, different smell agent to get the required color and smell. After that, we have to fill into molds and convert into soap parts. Then at the same temperature, we have to fill into molds, and when it is come to normal room temperature, they convert into semi-solid, solid structure. Then they are the soaps. Are you good? Okay, that's a full process of soap production. First, just can you summarize this very simple way? First, get triglycerides, oil required amount, and caustic soda aqueous solution in required amount. Then when heat the triglyceride mixture, 50% caustic soda add. Then after that, the final solution, after 30 minutes, get the final solution and separate by the separated funnel by adding sodium chloride to increase the density of glycerol. When it is separate the glycerol, and when it is centrifugate glycerol and soap separate as very clear layers, then we can separate glycerol. The separated glycerol again add sodium chloride and again separate soap, and again get the final soap solution. It contains sodium hydroxide, therefore the pH level is very high, well base. Therefore, we have to add citric acid to get the pH value into normal condition. Finally, we add filling materials. Normally, we add sand, silica sand, then calcium carbonate, sodium carbonate also possible. Then we get the final thickness with higher quantity, required quantity. Then we can add whatever coloring agent or smell to get the final product. Then fill into molds, and when it is come to the room temperature, they are converted to solid salts. Okay, now you have to prepare in your own word, you have to prepare a chart. Otherwise, this is very difficult. Okay, get a separate paper and prepare a own chart with each steps. With each steps to get the full idea in the future. Send me message after you complete the first page up to this level. First of all, you can as first step you can write heat the triglyceride solution. Heat the triglyceride solution. Second step, add 50% of sodium hydroxide aqueous solution. Likewise, in your word, you can prepare. Add 50% of sodium hydroxide aqueous solution. Third step, mix the solution to get the uniform product, uniform finer product. Mix the solution well. Okay, can you prepare your note? Fourth steps, separate by separating funnel after adding sodium chloride aqueous solution. Fifth solution, centrifugation. 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 Centrifugation means rotating. Okay. When it is rotating, low density particles go down, high density low density particles go up, high density particles go down. Okay, I'll repeat again. First of all, we need to get the required amount of triglyceride. Then heat the triglyceride solution. Then we have second step, we have to prepare sodium hydroxide aqueous solution 50%, then 50% of water and 50% of sodium hydroxide. Add, when it is heating, add the sodium hydroxide into the triglyceride mixture. Third step, we have to mix the solution well to get uniform final product. After mixing 30 minutes, we have to get the final solution and we have to add sodium chloride salts, aqueous solution to increase the density of the glycerol, to increase the density of the glycerol. After that, we need to add the final solution into the separating funnel and centrifugation. When it is centrifugate, high density particles go down and low density particles go up. Then the low density particles are soap, high density particles are glycerol. Then we need to, this two layer we can separate by separated funnel. We need to open this valve, then it is separate. After that, the separated glycerol, again we add sodium chloride and again check if there are any salts, if there are any soap available, then we again this, if there are any soap, again we add to the final product. After that, add citric acid to get the soap pH value into favorable, higher base condition into favorable neutral condition, and avoid damage of by unreacted sodium hydroxide. If there are any unreacted sodium hydroxide, we can avoid this damage by adding citric acid to get the pH value into favorable level. Then add filling materials. Normally we add sands and sodium carbonate, calcium carbonate also we can use. Then we need to grind this compound well and add as a filling material. Normally the filling materials quantity depend on the production quantity. That's depend, okay, that's depend on the production quantity. After that we need to add smell agent and coloring agent according to requirement. Then we can fill into required molds to get bars, to get soap bars. Are you okay? Yeah, small story. That's only you need to remember. Okay, I will show you how to produce soap in actually. Are you complete drawing? I will show you how to produce soap in actual in home condition. Now you can produce in your home, no? Simple. Only as citric acid you can use lemon. Citric acid contain lemon, you can use lemon. And but only you need coconut oil and caustic soda. Yeah, that's only required. You can try and if you produced, send me photo. Okay, I'll show you now how to produce it actually. Oh, can I erase this? Can I erase? Give me 30 seconds. I will show you how to produce soap in actual condition. In laboratory condition. Okay, send me, are you complete? Okay. Give me a second.
So friends, we all know the importance of soap in our life. For preparation of soap, we have taken 50 ml water in this beaker.
Okay. I'm going to show you how to produce soap in actual way, how to produce soap. Okay, if I play this, can you hear this sound?
And
Not my sound, the video sound. Can you hear?
in this bowl, there is sodium hydroxide. These are sodium hydroxide flakes. I've taken 15 gram sodium hydroxide and we'll prepare a solution of sodium hydroxide. Uh, 15 gram sodium hydroxide solution for preparation of soap. Let's stir and prepare the solution. Let's observe handling direction. Slowly the solution is
What he explained, this is a exothermic reaction. What's the meaning? That's powerful base and water reaction. That's aqueous solution preparation. That's a exothermic reaction. Exactly correct. That's exothermic. The sodium hydroxide powerful base plus water. We discussed in the thermal chemistry.
now the 15 gram sodium hydroxide solution is ready. We'll test whether it's base or acid. I have this red litmus paper, it has turned blue. And this is a blue litmus paper.
Red litmus paper convert into blue. Then what? It's a powerful acid. Then blue litmus paper, it don't have color change. Then it is by base. I think you remember in all.
No change in color. This
No change in color.
basic in nature. Along with this, it's quite hot, so we'll hold it.
Water exothermic reaction.
Along with
water.
it, we'll use 60 ml coconut oil.
Coconut oil.
And in this jar, I'll mix 15 gram of salt.
Salt. Sodium chloride. Sodium chloride.
Salt solution is also needed. I have taken 200 ml water and added 15 gram of salt. Sodium chloride. Now here it is 15 gram sodium hydroxide solution. This is 60 ml coconut oil and this is 200 ml water in which 15 grams salt is dissolved. Now we'll add this sodium hydroxide solution in oil. For this, we'll need another larger beaker. In this beaker, I'll pour the.
Okay, don't misunderstand. In this practical, they first mix in this triglyceride and sodium hydroxide, and after that they heating. But in our according to our syllabus, first we need to heat this triglyceride solution into required level and fight. After that we need to add in our syllabus, but in laboratory level they mix and after that heating. Don't think about that. Somehow we need to heat. Okay,
For this oil, and then
we add before heating they adding, but don't think about that.
So we'll hold it carefully. And while pouring, you have to stir the solution. Now I'm stirring. This mixture is ready. Oil and sodium hydroxide We'll heat this solution. For heating, we'll use this tripod, and to raise its height a little bit, I'll keep it on this corks. It's falling a little short, so I'm giving it a little height. And then this is a wire gauze. I'll keep it here on the tripod. And then
This is a Bunsen
put
burner.
this spirit lamp under this wire gauze like this, and put this solution for heating for 10 to 12 minutes. But while heating, remember to stir the solution continuously.
Yeah, continuous stirring is
Continuously
important. Mixing.
Stir the solution for 10 to 12 minutes.
Yeah, this mixing time is depend on the quantity. It is very small amount. That's why 10 to 12 minutes. When increase the quantity, production quantity, the reaction time must be more than that. Okay, I think you can understand. We can't exactly say this is the time, but according to the production quantity, that depend. Okay.
Take care not to boil over this solution, as we have taken a large beaker, so there is minimum possibility.
You can see when continuous mixing, the thickness, you can see thickness is increasing. Thickness increasing. See,
Our solution is boiled. Boiled solution is ready.
now you can don't think about the color. In here, he using a well purified coconut oil, but in Sri Lankan condition, our coconut oil is yellow color. There is special coconut oil, virgin coconut oil. Virgin coconut oil color is yellow color. When we produce soap in virgin coconut oil, the virgin coconut oil price is very expensive. They are very expensive. Therefore, in Sri Lankan condition, we not going to use virgin coconut oil for, that's yellow color coconut oil for soap production. Normally in Sri Lankan condition, we use in large scale hotels use one time used coconut oil, we use mainly for soap production. Therefore, in our productions, if you produce in your home, the thick solution is little bit yellow color, not like pure white color. Okay, in this, if you use yellow color coconut oil, you can get this white color. Okay,
We have boiled it for 10 to 12 minutes. And now we'll add this solution of
sodium chloride. After
sodium chloride,
thick solution, get add sodium chloride.
that is common salt, in this solution, and we'll stir it continuously. Thus, we have boiled sodium hydroxide and oil mixture for 10 to 12 minutes, and then mixed solution of salt and stir it. We'll let it rest for some time. Now we'll settle this layer.
Now you can see the lower layer. There are two layers clearly. Now you can see the lower layer is glycerol. You can see on the glycerol layer, the soap is float. Soap is floating. Okay, you see. Yeah, we need to keep some time for this separation. Without keep time, we can centrifugation. In this laboratory scale, they don't have centrifugation facility. That's why they keep some time. But in industrial process, they're not going to keep some time. Just they centrifuge. In centrifugation, the low density particles go up, soap particles go up, and the glycerol particles quickly go down.
Due to chemical process, the soap floats on this mixture and it has got thick because we had let it settle down for some time. Now we'll separate this soap in a mold.
That's not the recommended method. Okay, in your home you can use this method because you don't have separated funnel. Normally after this soap is after we adding sodium chloride solution, you have to centrifuge it. Centrifugation, we can just separate this glycerol and triglyceride. After that, we have to separate by a separated funnel, separating funnel like Buckner funnel we discussed last week. We can separated funnel we can use. Then separating funnel එකෙන් තමයි මේක separate කරන්න ඕනේ. Okay, after that we can fill into molds.
This thick mixture.
That's a still thick mixture
for some time so that it becomes thick.
Yeah, it's keep for cooling 2 to 3 hours. Keep for cooling.
Now you can see a thick
now it is
found in this mold. We'll soak it with a filter paper.
Okay, then this is the so
we'll take it. See, so by the
if you produce, you can try. If you produce, if you follow this step, I think exactly you can't get this like baby soap color. It's come like sunlight. Okay? Yellow color is come because our coconut oil is a very low quality. Normally we use coconut oil. If you use very like if you use very pure white color coconut oil, you can get this color. Okay, normally in Sri Lankan condition, do you know, for soap production we use used oil. Yeah, they don't adding, but in when we produce they are produced for experiment, we have to add. Don't think about this step. You only need to get idea from this video. This is the steps. Okay, they are the step. I think now we have to add citric acid, but they don't adding. But you have to remember, we have to get the pH value into favorable level. They are not producing for use, no. They are in laboratory level as experiment. But in our production for usage, for apply in skin, we have to get the pH value into favorable level. Otherwise, it is huge damage. It is burn our skin. I got full idea about soap production. Any doubt? Any doubt in soap production? You can ask. Any doubt? No doubts? So is there a specific temperature the mixture is heated? Yeah. Normally don't have a specific in different soap production, the heating is different temperature. Normally it's no more than 100. It's 80 to 90 Celsius range is enough. 80 to 90. 80 to 90 Celsius is enough. If it is more than this level, it is when we adding sodium hydroxide, it is just the reaction speed is very high. If we increase the temperature more than this level, the mixing should be very well. The temperature is doesn't matter, but you know the temperature increase, the oil temperature increase, the reaction speed what happened? The reaction speed is very high. Therefore, if you heat this into more than this level, you have a proper mixing method. You have a quick mixing method. Otherwise, the reaction speed is very high. It can be damage to our product, final product. If it is not uniformly reacted, it is the final product qualities become lower. I got it don't have a specific temperature level, but the heating temperature should be according to the reaction, according favorable for our reaction. Any other doubt? Any other doubt in soap production? Yeah, one question. So what's the ratio of adding triglyceride and sodium hydroxide? Triglyceride and sodium hydroxide better to add in same ratio. If it is, you know, they are, if it is sodium hydroxide is more greater than triglyceride, sodium hydroxide is remain. If it is triglyceride is greater than, the amount is greater than sodium hydroxide, triglyceride is remain. Always we have to maintain in large scale production process, it is they have maintained continuous reaction. Continuous reaction means sodium hydroxide continuously produce, continuously supply sodium hydroxide aqueous solution, and triglyceride continuously supply. Now in here we discussed about the batch type. No, in this batch type, we better to use in same amount, same ratio, 50% to 50%. Am I okay? I got the reason. The reason is important. Sodium hydroxide, if it is greater than triglyceride, sodium hydroxide remain. The triglyceride is limited. So sodium hydroxide limited, triglyceride is remain. That's the economical damage at the final product. The whatever raw material is remain. The better to use in same ratio, 50 to 50. Approximately same ratio. Okay. Okay, other. Okay, go to the tute. Now time enough for soap production, 8:55 now. You can read this, the production process of soap. I have given everything. Saponification is a chemical reaction that takes place in soap production. It is byproduct is glycerol. Because the mixture vegetable oil, animal oil, and aqueous caustic soda don't mix with each other, there are two zones, and glycerol formed in the aqueous zone is separated from the aqueous zone and float the water because of the low solubility of soap in soap is low. The resulting soap containing some glycerin, unreacted oil, and caustic soda we discussed. The caustic soda harmful to the delicate tissues in our skin and eyes. Caustic soda should be neutral because a reaction between liquid zones and immiscible liquid zones and take place soap production. It is very important to mix those two zones well at the beginning. It is important to separate the aqueous zones with glycerol and soap. Caustic soda should be neutral. I forgot about give you adding citric acid for separate neutral. Adding citric acid for neutral, that's you have to note down. Adding citric acid for neutralization. Adding sodium chloride is aqueous zone, to the aqueous zone can reduce the amount of dissolved soap in aqueous zone. Due to the increase the density of the water zone, the soap can be easily separated from the water zone by causing the soap to adhere in water zone. Okay, very simple. Everything I have given, the density increase, that's why we can separate the soap as a bowl layer because the soap density is very low. It was determined that about 30% of water is present in the soap, and when it is heated up to 70 Celsius, wet soap become easily pumpable. They are not important. Reaction chamber, they are reaction chamber things, they are not important. Okay, go to the next page, page number 8. To remove amount of glycerol contained in the wet soap, again mix it salts. I explained again the separated glycerol again mixed with sodium chloride. Then we can again centrifugation, and if there are any remains soap, we can get again. Okay, I have given this the all steps in soap production. You can read. Okay, next page, go to the preparation of soap sample in laboratory level. Okay, you can read this same mechanism as we discussed, same method that as we discussed. You can read them. with the basic, if you know the basic steps, you can read and understand. Okay, now 2 points we have discussed. Another 2 point. Another 2 point we have discussed. How the soaping process, washing process of the soaps. How wash any impurity. Wash any impurity. How remove any impurity by soap. What is a soap? The sodium stearate. No? The sodium stearate is, this is the structure. I think you remember. The R is this is a soap structure, the chemical structure of soap. What is this? What is this? This is the R carbon chain, because this is the normal structure we discussed last. The structure of sodium stearate, the R is the R carbon chain in the fatty acid. We discussed, okay? We have discussed in fatty acid has R carbon chain, that the number of carbon, it is more than 12 and between 12 and 24. We discussed in biomolecule lesson. The number of carbon in the R carbon chain, it is higher than, more than 12 and less than 25. No? Okay, the different types of fatty acid produce, the number of carbon is different. Okay, the number of carbon is different according to the fatty acid. Okay, then that is a long carbon chain in the fatty acid. Then this is the structure of soap. This is the structure of soap. Now, this is the structure of soap. Now, there is a special name for this part. Okay, come to the first page of soap production in the page number 6. Come to the page number 6. Page number 6, I have given the structure, but the head and tail I have changed. Okay, head and tail. This is we called as hydrophobic head. This part is head. Hydrophobic head. This part is hydrophobic tail. This part is head, this part is tail. And remember that this part, the head is polar. Head is polar, the tail is non-polar. The tail is non-polar. Now, anyone can you explain? Now think there is a cloth, whatever surface, there is a oil stain on this cloth or whatever surface, there is a oil stain. Okay, if I wash this cloth by water, is it removing? If I wash this cloth by water, is this oil stain is removing or not? Not removing. Why? The water is polar, the oil stain is non-polar, therefore the water and oil not dissolve each other. Good. Now, can you explain? Normally, if I wash with soap, then it is removing, no? Normally, you can try. Normally when after food plates and normally the oil stains, if you want to remove oil stain, we have to whatever type of soap. by only water, it's not removing, no? Why? How soap remove these oil stains? Whatever non-polar impurities, how they remove? Can you anyone explain? I think the question is clear. Oil stain or whatever non-polar stain cannot remove by water, but they are removing with soap. How it is? This is the structure of soap, chemical structure of soap. Anyone can? How it is removed? Okay, what do you think? Two answers. Soap tail dissolve in the stain and removes. Very good. It is dissolved in non-polar tail and by the polar head. Very good. Very good. The hydrophobic head attached to the oil and the hydrophilic tail attached to water. No, wrong. Amaru. Hydrophobic head is polar. Hydrophilic tail is the non-polar. Then you have changed the side, two sides. Okay, understand? Normally, if I wash with any oil stain with water, they are not removing because the oil stain is non-polar compound. The water is a polar solvent. They are not dissolved in water. Therefore, the oil stain is not. When we apply soap on this cloth, what happened? The soap contain hydrophobic head and hydrophilic tail. Now the hydrophobic head is polar, hydrophilic tail is non-polar. Remember, non-polar means it is fatty acid. No, fatty acid is non-polar. This part is head is polar. Then the oil stain, when we apply soap, the oil stain dissolve in this non-polar part, non-polar tail. Oil stain dissolve in this non-polar tail. First, when we apply soap, sabangadi, then oil stain dissolve in non-polar tail. Okay, after apply soap, what we need to do? We need to wash with water. When we washing water, the hydrophobic head is dissolved in water. Then hydrophobic head dissolved in water and remove. We can remove this soap. With water. Then the oil stain, whatever non-polar compound dissolved in the hydrophilic tail, and after washing with water, the hydrophobic head is dissolved in water. Entire soap molecule we can remove by water because of this hydrophobic head is dissolved in water. I got? Hydrophobic head is dissolved in water. Then hydrophobic head is dissolved in water. Entire soap molecule we can remove by water because of this hydrophobic head is dissolved in water. I got? Hydrophobic head is dissolved in water. Entire soap molecule we can remove by water because of this hydrophobic head is dissolved in water. I got? hydrophobic head එක වතුර දිය වෙනවා. Therefore මේ compound එකම we can remove by water final washing. First of all, when we applying soap, the non-polar compound dissolve in the hydrophilic tail. I have given in the first page hydrophobic hydrocarbon tail. I have, there are mistake now. The head is hydrophobic head. Hydrophobic head, it's correct. But in the tube given hydrophobic tail, it should be hydrophilic tail. Hydrophilic tail. Hydrophilic tail. Hydrophilic tail. Okay, I will correct hydrophilic tail. Hydrophilic tail. Hydrophilic tail. Correct this. Hydrophilic tail and hydrophobic head. Hydrophobic head is polar, other side tail is non-polar, then oil is strain dissolved in non-polar. Oil is strain dissolved in non-polar part. The entire compound is remove with final washing with water. That's the washing process of soap. Washing process of soap. Okay. Now 9:11. Today I hope to complete the biodiesel part as well. Then I will give you a break and we can start biodiesel. If you understood soap production well, biodiesel we can complete 30 minutes, with approximate 30 minutes we can complete biodiesel. Then 80% of lesson complete if you complete biodiesel. Then we next day we have to the paint production also we can complete today. Next day we have fertilizer and paper. That's easy. You have homework. You have homework. You have homework. This is today I explained about normal soap production. Okay, normal the soap sodium stearate production. But in the market there are different types of soaps. No? There are different types of powder soaps, liquid soaps. Then you have to refer about. I have given only a few points how to produce liquid soap. Next day, before next day, I have explained the basic full concept. Now you have to find out in internet or whatever source, you have to find how we produce powder soaps and how we produce liquid soap. That's your work. You have to find. Then I will ask one by one what is the difference between the difference between detergent and soap. Yeah, that's why I ask you. The detergent powder and whatever powder soap and the liquid soap, how to produce. Okay, I have small confused words. Doesn't hydrophobic mean water fairing? No. Wait. Wait, in the tute, both given in hydropebic, no? Hydroprobic. Yeah, I know. I need to check with my other note. Wait. Yeah. I have changed the site. Sorry. The head is polar, it's correct, but the word is changed. Word need to change. Yeah, good point. The hydrophilic head and hydroprobic tail. It should be changed. Sorry. Hydroprobic. Yeah, correct days. Yeah, good point. I have changed them. But because in the tune both words as mistake it was hydroprobic, no? The tail hydrophilic head and hydroprobic tail. Hydroprobic tail. Hydroprobic tail. The tail is the non-polar one. That's correct. The head is polar. Head is polar. Head is water dissolved. Now okay, no? Sorry. The two words. I was confused because of the tute given the same word because okay. Now okay, I'm out. Okay, now okay. Hydrophilic head and hydroprobic tail. Now okay. Adisha, I have given in the Sunday hydroprobic. කොහොමද මන් දුන්නේ? Hydrophilic and hydroprobic කියලාද? මාරු කරලාද? Adisha, how I given Sunday? Yeah, change, no? ඒක මතක් කරන්න හදන්න next week. It should be hydrophilic head and hydroprobic tail. No, this one I asking. Adisha. Sunday I given hydroprobic tail or hydrophilic tail. Okay, somehow I will correct it in Sunday. Okay, this is the correct one. Hydrophilic head and hydroprobic tail. The hydrophilic head is water soluble. Somehow head is water soluble. Remember that tail is non-polar. It is dissolved in non-polar compound. Okay, correct. It should be correct into this. Okay, I will explain next Sunday. Okay. Okay, this is your homework. This is your homework. Okay, now any doubt in soap production? Any doubt? Are you got all the raw materials? Now, can you answer my questions? What is the main raw material for soap production? Send answers. Has summarized the soap production process. What are the main raw material? Soap production. Quickly, quickly. I need to finish this and give you break and go to the biodiesel production. Yeah, send me all. What are the main raw material for biodiesel production? Others? Yes. Then what is the main chemical reaction name? What's the main chemical reaction name? Chemical reaction name? Saponification. Very good. What is the main byproduct? Main byproduct in soap production process? Main byproduct in soap production process? Very good. To increase the density of the glycerol, what we add? To increase the density of the glycerol, what we add? Salt. Sodium chloride. Sodium chloride salt. To get the pH value into favorable level, what we add? Citric acid. As filling material? As filling material? As filling material? Yeah, sand is correct. What are the other types of filling materials? Sodium carbonate, calcium carbonate. Okay, that's all about soap. Find about what is the difference between the basic soap and powdered soap and liquid soap. Okay, soap powder and soap liquids, detergents, and whatever shampoo or whatever liquid soap. Okay, get a break and we start again 9:40. Okay, 9:40. Join 9:40. 9:40. Join on time. We discussed the biodiesel production and they are all practicals, all steps we discussed. Therefore, get break 15 minutes and join 9:40. Can you hear me? Yes. Okay. Okay. Yes. Okay. Now we're going to discuss about biodiesel production. This is our second chemical industry in our syllabus. Second chemical industry, biodiesel production. Biodiesel production. Do you know? Normally, normal diesel we use for our nowadays for our vehicles. What is this type of diesel? That we called as petroleum diesel. Petroleum diesel. Where it is from where we got from this petroleum diesel? From crude oil. From crude oil. Then how produce crude oil? How produce crude oil? How produce crude oil? Okay, before we go to the discussion of biodiesel, we discussed about petroleum diesel. Why we need this biodiesel? We can understand why we need this biodiesel by if you understood about petroleum diesel. Petroleum diesel mean petroleum diesel. Petroleum diesel. Petroleum fuel, not only diesel. Diesel, all petroleum fuels, all petroleum fuels, all petroleum fuels starting from fossil fuels, fossil fuels, fossil fuels. Then fossil fuel convert into crude oil, crude oil, crude oils. Then crude oil purification, we can get the crude oil purification, we can get the petroleum, kerosene, whatever oil, whatever fuel we petrol, diesel, the petroleum fuel we can get. Petroleum fuel, petroleum fuel, petroleum fuel. Okay, do you know this petroleum fuel? Now tell me, the petroleum fuel is renewable energy source or non-renewable energy source? The petroleum fuel is renewable energy source or non-renewable energy source? What do you think? Petroleum fuel, renewable energy source or non-renewable energy source? Petroleum fuel, renewable or non-renewable? Okay, what do you think? Petroleum fuel, renewable or non-renewable? petroleum fuel renewable or non-renewable? What do you think? Renewable or non-renewable? Others? Only 3 answers. Yeah. Then what is the meaning of non-renewable? Yeah, all answers non-renewable energy source. Then what is the meaning of non-renewable? Meaning? What's the meaning of the non-renewable? No. Not can use only one time. Not that's not the meaning of the non-renewable. Yeah, that's in one side it's correct, but what is the actual meaning of the non-renewable energy source? Non-renewable mean like this. Actual meaning is non-renewable. Think this is the energy source when it is using the product is produced, the producing product again not convert into the if it is correct meaning, Chevon, you are correct. If it is correct meaning, it's not again remake, it's not again produce after we use. That's a non-renewable energy. But can't produce. That's the actual. Okay, that's the actual meaning is again not producing energy source, non-renewable energy source. Then how produce fossil fuels? Do you know fossil fuels how produce? The main source of petroleum or whatever petroleum, whatever fuel, the fossil fuels. Fossil fuel is the fossil is the main source. Then how fossils are produced in the lower level of the earth? The fossils are produced because of things. This is the earth. On this earth, plant parts, dead plant and animal parts, millions of years after millions of years, more than millions of years, collecting this dead plant parts and organic parts, then produce energy that we called as fossil fuels. Then one type of fossil fuel is a crude oil. The crude oil we can separate different types of petroleum fuels. Okay, then why you say again is not produced? The petroleum diesel actually again produced. Why? The continuous plant and animal death material add to the our soil, our earth. Then after millions of years, again they convert into fossil fuel. Then we can again use. Then why? Then why we call the petroleum diesel actually the petroleum fuel actually non-renewable energy source? Then why they are producing again and again they are producing? Then why we call as the petroleum diesel non-renewable? Yeah, you are correct. Your answer is correct, non-renewable, but your reason is wrong. Yes, Amavi doesn't regenerate. It is a non-renewable. But I asked why the petroleum diesel actually regenerate, but the petroleum diesel we consider as non-renewable energy source. I asked what is the reason for that. Actually, the non-renewable energy source mean again not producing, not generate again the source. Yes, Adi. Again not producing. That's the meaning of non-renewable. But the petroleum diesel is producing again and again. Continuously plant animal part add to the earth, then again it's producing. It's producing. But petroleum fuel we consider as non-renewable energy source. Problem, no? The petroleum diesel again and again producing, fossil fuels also producing, but the problem is according to the usage, according to the usage, according to the production, the production speed is not enough according to the usage. Okay, think within 1 year, nowadays within 1 year, the crude oil, think 100 tons of crude oil use entire earth, they produce only approximately, they produce only within 1 year, produce only 2 tons like this within 1 year. You can see the consumption and production has a considerable gap, huge gap between production and consumption. That's why according to the consumption, the production speed is not enough according to the consumption. That's why we call any day in the future, the petroleum diesel is finished. Petroleum diesel is complete in entire earth, because petroleum fuels are complete, because according to the consumption pattern they are not producing. I got, that's why we call petroleum diesel are considered as non-renewable energy source. Yes, Amavi, correct. That's why we call petroleum diesel is a non-renewable energy source. Then there is in the tube, there is a theory called as Herbert law. There is a theory called as Herbert law. Herbert law. Herbert is a scientist. Herbert law. Herbert law. The Herbert is a scientist. He have explained about the consumption pattern of these petroleum diesels and petroleum fuels. He have explained he has explained he has explained think this is the time. This is the time by years. Time years. This is the consumption. Consumption. The Herbert is a scientist. He has explained about the consumption pattern of petroleum diesel. He has explained the consumption of the petroleum diesels in near future. It is start to gradually increasing like this, and it's come to the maximum after few years. In few years, it's come to a maximum level. That's the maximum consumption level. It's come to a maximum consumption level. And after that level, again decrease the consumption like this. Again decrease the consumption, that we called as Herbert law, Herbert theory. He has explained, I have given in the tube, he's explained the Herbert theory state the proximate depletion of non-renewable sources petroleum fuel depends on the pattern of human consumption of petroleum. According to the Herbert law, the fuel production and consumption reach the maximum, and then it is production and consumption gradually decreasing. Okay, that's the Herbert law. In the given space, you have to draw this space. You have to draw this graph to explain the Herbert law. The Herbert law most possible MCQ question in the exam MCQ paper. What is, who explained about the consumption pattern of the petroleum fuel? It is, he is, Herbert is the scientist. Herbert is the scientist. Herbert is the scientist. Herbert is the scientist. Herbert law. Herbert theory. Okay, Herbert theory. Okay, now okay, when we consider about, I will explain what is the difference between this petroleum diesel and biodiesel. When we consider about petroleum fuel, that's the cycle of petroleum fuel. Petroleum fuel. Petroleum fuel. Petroleum fuel, it is starting from fossil fuel. Fossil fuel. Fossil fuel. It is starting from fossil fuel. Then the fossil fuel given petroleum fuel. Petroleum fuel. Petroleum fuel. Petroleum fuel burning, whatever engine or whatever machine petroleum fuel burning, what is produced? Do you know hydrocarbon? Any hydrocarbon burning, what is producing? In polymerization we discuss it. In any hydrocarbon, any fuel burning, compulsory produce carbon dioxide plus water. Carbon dioxide plus water. In, do you know, in vehicles annually need to get emission test. In emission test, what we testing? Emission test, what is testing? Do you know? Yeah, they are practical things, the general things. Normally in vehicle emission, normal composition is carbon dioxide and water. Carbon dioxide and water. In vehicle emission test, what is testing? Which gas is testing? Normally vehicle emission test, they are testing carbon monoxide. Do you have heard? Carbon monoxide, CO. The carbon monoxide is produced because of incomplete burning in the petroleum fuel. If it is complete burning, carbon dioxide and water is releasing. If it is incomplete burning, carbon monoxide is produced. The carbon monoxide is not favorable for environment. The carbon dioxide, no more damage. No, it has damage, we discussed in the environmental chemistry lesson. But when compare carbon monoxide and carbon dioxide okay, because carbon dioxide is a carbon dioxide absorbed by plant and again photosynthesis. But carbon monoxide is environmental unsafe gas. That's why in vehicles, the carbon monoxide percentage, CO percentage, we have to keep in standard within the range. Within the range. Normally, the carbon monoxide emission, there is a range, acceptable range. If there, if this any vehicle within this, not in this range, the carb emission test is failed. Then we have to again repair and get the emission test. There are extra things. Okay, normally the carbon dioxide and water is produced. Then carbon dioxide and water important produce plant. No? That is produce plants. Then plants, and when it is plant produce, animals also produce. The plants are the food so animals. Then animals also producing animals. Then animals and plant death, fossil fuel burn, death animals and plants, the fossil fuel burning. Then it's like a circle. It's a circle. The petroleum fuel also, it's going a circle. But what is the problem? This circle is getting more than millions of years. According to nowadays consumption of the petroleum fuel, the production rate is not enough. That's why we call petroleum, actually, if it is the correct meaning, petroleum also a renewable energy. No, the petroleum, if it is consumption in normal range, consumption in producing range, it also a renewable energy source. It's also a cycle. It has also a cycle. But the problem is what? Nowadays, because of the higher population in the human, and because of higher technology enhancement, the petroleum diesel drastically increased the consumption. That consumption rate is more than the production rate. That's why nowadays the petroleum diesel, petroleum fuels, we consider as non-renewable energy source. Now we'll see the difference between, this is the petroleum diesel. Now we'll see what is the difference between biodiesel with petroleum. Okay. Now come to the biodiesel. The biodiesel is like this. Biodiesel. The biodiesel, or bioethanol, or whatever biofuel. Biodiesel. Biodiesel starting from, I will start biodiesel from biodiesel. When it is biodiesel burning, again same, biodiesel burning, CO2 plus H2O is producing. CO2 plus H2O is producing. Carbon dioxide and water is producing, water vapor. Then these both carbon dioxide and water vapor important for plant development. Plants absorb plants. The water and carbon dioxide absorbed by plants. After that, this plant absorb, then the plant growth is increasing. When carbon dioxide is increasing, plant's growth, plant photosynthetic increasing. Therefore, understand the methanol, and I will explain what are the methanol is. Methanol and triglyceride. Methanol and triglyceride production also increase. The methanol and triglyceride are the main raw material required for biodiesel production. I will explain in the next part. The methanol and triglyceride production, both plant related production. Methanol is, if you don't idea about methanol, think about methanol equal to ethanol. The methanol is a ethanol like solution. Okay, ethanol we can produce from plant material. Then this is triglyceride. The triglyceride mean oil. No? Then they are the raw material required for biodiesel production. Okay, now using this two raw material, we can produce biodiesel. We can produce biodiesel. Okay, now biodiesel again burning produce carbon dioxide, water, then produce plants, methanol and triglyceride, again biodiesel. That's a quick cycle, no? That's a quick cycle because plants development and this triglyceride production not like millions of years. It produce within 2 to 3 years. Triglyceride produce one plant, but it's not like time consuming. The time consuming is very low in this cycle. That's why we call biodiesel is renewable energy source when compared with the petroleum diesel. I got the point. The methanol, triglyceride, the raw materials I will explain in second part. First, understand why we consider biodiesel is renewable energy source and petroleum is non-renewable energy source. Understood? Do I need to explain anyone? Again? Quickly. Now 10:08. We have only 50 minutes. We need to complete biodiesel. I got? Yes or no? Yeah, the reason is petroleum diesel and biodiesel, both they are cyclic manner, but the problem is petroleum diesel production time is, it is a considerable huge value, huge time is taken for production. But comparing biodiesel raw materials producing within several years. Therefore, it is raw materials again and again produced. The biodiesel biodiesel burning, the releasing product important to again plant development. Understood? Therefore, it is a quick cycle. Okay, I have given space for in the tube page num in the next part of the biodiesel, next page of the biodiesel part, page number 2. You have to draw both petroleum diesel and biodiesel cycles in the given space. Complete? Complete? I complete? Complete? I sleep. Okay. Now this 30 minutes is very important. I'm going to explain about biodiesel production. Same as soap production. If you understood well, don't need to again remember anything. Okay. Don't need to try effort to remember anything. Everything I will explain now. Okay. In biodiesel production, the main raw materials in biodiesel production, remember biodiesel production main raw materials are same as previous. The main very important raw material is triglyceride. Triglyceride is the main raw material. Triglyceride same as soap production. Triglyceride plus in soap production, second raw material is what? Sodium hydroxide. But in biodiesel production, then we not going to, the sodium hydroxide not a raw material. The raw material is methanol. Now you already know methanol is the raw material. Methanol is the raw material. Then after that, after reacting these two raw materials in the reaction chamber, then produce biodiesel. Biodiesel is produced. Biodiesel plus same as soap production. The byproduct is same, glycerol. The byproduct is same, glycerol. The byproduct is glycerol. The very important thing is in soap production, don't mix up these. Though in soap production, the sodium hydroxide is a raw material, but in biodiesel production, sodium hydroxide is a catalyst. Sodium hydroxide is a type of catalyst. Main catalyst is sodium hydroxide. The sodium hydroxide acts as a catalyst. In soap production, the entire reaction we called as what? Saponification. No? Saponification. In biodiesel production, the full reaction we called as a single name, that is transesterification. Transesterification. Are you good? The transesterification mean the triglyceride plus methanol react with sodium hydroxide catalyst, biodiesel and glycerol is production. The main product is biodiesel. This is the main product. As byproduct, byproduct, the glycerol is producing. As byproduct, the glycerol is producing. I got the basic understand about the biodiesel. What is the name of the reaction? Trans-esterification. What are the raw materials? Triglyceride plus methanol, then produce biodiesel plus glycerol. Glycerol is a byproduct. The main product is biodiesel. Main raw materials are triglyceride and methanol. The catalyst is the sodium hydroxide. Don't mix up. In soap production, what is the catalyst? In soap production, what we use catalyst? In soap productions, what we use catalyst? No answer. I asked in soap production, what we use catalyst? In biodiesel production, the catalyst is sodium hydroxide, caustic soda. In soap production, what's the catalyst? Quickly. Others? Yes. In soap production, we know. Then, do you remember sodium chloride is what? In soap production, sodium chloride is? In soap production, sodium chloride is catalyst. No, remember, okay. In soap production, sodium chloride is not a catalyst. That only we use for increase the density of glycerol. Increase the density of glycerol, then the density increase, the layers separate clearly. Then we can easily separate by separating funnel. Okay, that's soap production. In soap production, don't have any catalyst. In soap production, don't have any catalyst, but in biodiesel production, what are the raw materials? Raw materials are triglyceride and methanol. Then produce biodiesel and glycerol as product. The main product is biodiesel. The byproduct is glycerol. The main catalyst we use sodium hydroxide. Sodium hydroxide is main raw material in soap production. But in this biodiesel production, that's the main catalyst we use. The entire reaction of this biodiesel production we called as trans-esterification. Trans-esterification. Are you got the basic? Yes or no? Have you got the basic idea? Okay. Okay, now come to the trans-esterification. Trans-esterification. That one don't need to write. You only need to write in the tube trans-esterification. 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 Okay. Trans-esterification. Come to the trans-esterification. 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 Okay, what is the meaning of trans-esterification? In trans-esterification, What is this? What is this? What is this? What is the name of this structure? Now I am going to explain. In the soap production also we discuss this structure. What's the name? Triglyceride. Very good. Triglyceride. This is a triglyceride. Now, triglyceride plus, understand very well, triglyceride plus methanol. What is the chemical structure? Methanol. Methanol, what is the chemical structure? Methanol. Methanol, what is the chemical structure? Remember, the methanol structure is CH3OH. CH3OH. CH3OH is the methanol. They are very important. Okay. MCQ, most possible questions. Okay. Finally, the sodium hydroxide is a catalyst. I will write according to my space. I will write this is a catalyst. This is a catalyst, sodium hydroxide. Then what is produced? Very careful. Understand carefully. Same as previous question. In this trans-esterification, the name also given this esterification. Esterification means same as soap production. The ester bonds are breakdown. Breakdown ester bond and CH3. CH3 combined with this fatty acid. CH3 combined with this fatty acid, same as previous. CH3 combined with fatty acid. That means CH3 oxygen this is the biodiesel. This is the methanol. This is the biodiesel. Biodiesel, the esterification, CH3 and fatty acid connecting. CH3 and fatty acid connect each other. Finally, this OH connect with this CH2. Then finally produce CH2 connect with OH, CH connect with OH, CH2 connect with OH, finally produce, this is, what's the name? CH2OH, CHOH, CH2OH, very good, glycerol. 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 This is the glycerol. This is the glycerol. Then you can see triglyceride plus methanol. Then by using sodium hydroxide catalyst, the biodiesel and glycerol is produced. Remember this methanol structure, and now you familiar, triglyceride you familiar. Remember the methanol structure and biodiesel structure. The glycerol also you can remember. Previous one also say the biodiesel CH3 contact with the fatty acid. Then for balancing, we need to add 3 and 3 here. Now it is balanced. Okay, this is the full structure of the trans-esterification. Are you got? That's the full chemical reaction of the trans-esterification. Are you got? Okay, page number second page of the this one, the middle space you have write down about trans-esterification. I don't have given here. Write down topic trans-esterification and write down this this one. At the end of this part, now 10:30, 11 p.m. I will show you how to produce biodiesel in practically, how to in actual way, how to produce biodiesel. Therefore, don't wait until 11, only 11. After that, the biodiesel complete, we finish for today. The next week we start, next week within very short time we can complete paint production, fertilizer production, and paper production. They are very easy. This is the actually very difficult lesson, the biodiesel and soap production. It's the chemical reactions a little bit complex in soap and biodiesel because they have a specific chemical reactions. In soap production, saponification; the biodiesel production, trans esterification. In paint production, fertilizer production, paper production don't have a specific chemical reaction. It only the chemical industrial process only we need to understand. Okay, complete. Complete. Completed. Okay, good. Okay, now I'm going to explain how to produce biodiesels. Can I raise? How to produce biodiesels in actual way, in practical way. Okay, first of all, same as soap production. Can I raise? Send me yes or no. Okay. Okay, same as soap production. First of all, we need to get a triglyceride solution. Triglyceride solution. Same as soap production, we need to get the triglyceride solution. Triglyceride solution. This triglyceride solution, that's according to our requirement. Okay, the amount is depend on our requirement, the production quantity. Okay, then we need to get say and same as soap production, we need to heat this triglyceride and we need to add uh, the methanol solution. We have to prepare CH3OH methanol solution. Same method we have to add into the, when it is heating, the oil is heating, we need add into this triglyceride and mixing well. Same as previous, mixing well to increase the collisions between these two reactant molecules. We need to mix well, stir well this mixture until the reaction is completed. Until the reaction is completed. Now, until after reaction complete, the solution, the final solution. Before that, I forgot. Before complete the reaction, yeah, when it is heating, we need to add methanol solution, and after that we need to add sodium hydroxide as well. This is the sodium hydroxide is the catalyst. No? Without catalyst, the reaction is not the very slow. The reaction is very slow. To speed up the reaction, we have to add sodium hydroxide, caustic soda. This is a catalyst. Sodium hydroxide catalyst. Then we need to mix this solution well, mix this until the reaction is complete. Okay, when we add methanol and sodium hydroxide into the triglyceride, what is the main problem occurred in the final solution? Finally, after reaction, what is the main problem happened? Can you imagine? There is a huge considerable problem coming in this process, in this reaction. If I explain more, because of this sodium hydroxide use, special problem is coming. What do you think? Because of this caustic soda used for this production process as catalyst, a special problem is formed, coming. What is the problem? Special problem is coming. Yeah, very good, Amar. Amavi, yes, forming is correct. Yeah, why its form is coming? Forming. Yeah, forming is the problem, yes. On the produced biodiesel, the final product, the form is coming. What's the reason for that? That's why I ask. What's the reason for this forming? Others, what do you think? Actually, when because of use this sodium hydroxide, caustic soda for as catalyst for this production process, final product, a foam is coming. Pena. then the quality of the biodiesel is become lower. Then what is the reason for this form? Very good, Shavon. Very good, Adish. Others? The reason is in this reaction, triglyceride and as caustic, so as catalyst we add caustic soda. Therefore, if we add methanol, some part of triglyceride react with this sodium hydroxide, caustic soda. Then sodium hydroxide and caustic soda reaction, what is the reaction? Saponification. Because of saponification, some part of soap, some small amount of soap can be formed. That's the problem. Because of that, small forming is coming on the biodiesel solution. I got? Okay, now the after reaction is complete, then the reaction time is depend on the quantity. Okay, reaction time depend on the quantity. After reaction is complete, what are the composition of this solution? Composition, yeah, it's contain biodiesel, the product, and it's contain glycerol, no? Glycerol, the byproduct. What are the other? It can contain unreacted methanol. Yeah, that's all, and small amount of unreacted triglyceride, and other thing is unreacted sodium hydroxide, not unreacted. That's a catalyst, no? The catalyst always not reacting, remember. If it is reacting, it's not a catalyst. If it is actually small amount is reacting, but it's the catalyst must be remain. Okay, catalyst must be remain, as the finally catalyst must be remain without any change, without any chemical change, okay. Then sodium hydroxide remain, methanol remain, glycerol remain, biodiesel is a product. After that, first of all, now this is the production process, actually the complete. Now after that we going to discuss about the purification of biodiesel. This is a production, simple. This is a production, and it can contain some soap, no? Soap. Okay, that's the composition of this final solution. Okay, now the soap layer, first of all we can filter and remove this foam layer. We can filter and remove this foam layer, then I will remove this soap layer. Soap is okay. Now this biodiesel contains some amount of glycerol. Remember that. Glycerol is the biodiesel and glycerol actually separate layers. By when we add this into the separating funnel, the biodiesel is non-polar. Glycerol is polar. Therefore, it is no need to density difference. It is automatically become as 2 layers. Remember that. It is auto convert when it is centrifugation. This just separate into 2 layers. Then I can separate. Always the glycerol layer is lower because glycerol density is high, comparing high. If it is separate, high density particles go down. Okay, therefore density is high. The glycerol, higher density glycerol we can separate first, and we can separate the biodiesel. Okay, now the glycerol is okay. Glycerol we remove. Now this separated separated solution, again separated solution, it can contain what? After separation glycerol, its composition is don't have soap, don't have glycerol, it contain biodiesel. Understand final part, biodiesel and methanol and sodium hydroxide. Normally sodium hydroxide we add as a catalyst, no, therefore it is no any difference, it is no any difference, therefore sodium hydroxide we can as if we add as precipitation or whatever, I will show you, we can, normally we filtering we can remove this sodium hydroxide. Okay, sodium hydroxide, actually this sodium at the filtering process, we can remove this soap and sodium hydroxide both. Filtering process, soap and sodium hydroxide we can remove. Okay, sodium hydroxide not reacted, that's a catalyst, we can remove. Then glycerol, okay, biodiesel and methanol mainly contained in this. Biodiesel and methanol after separated, biodiesel and methanol. Okay, now how we remove methanol? How we remove methanol? How we remove methanol? Methanol we removing by heating. Remember, heating the slightly the biodiesel solution, final biodiesel solution we heating. When we heating, the methanol is evaporated before biodiesel. Before biodiesel, methanol is little bit volatile compound. Methanol is evaporating first. Therefore, we separate. We can still, if you want, we can collect this evaporated methanol and again use for biodiesel process. That's also a circle. Okay, then I need to heat that and remove methanol. If any remain sodium hydroxide, if any after this purification process, if there are any remain sodium hydroxide, I can remove that by water. We add some like a washing by water. I will show you how to do it. We can add some amount of water, and the water and biodiesel is not mixing. That's a two layer. Then if there are any sodium hydroxide remain in the biodiesel, the quality is low. Therefore, if there are any sodium hydroxide as catalyst, we use sodium hydroxide remain, we can add water, some amount of water, and the biodiesel and water is separate layers. Then sodium hydroxide easily dissolve in water. Then we can, with water we can remove. I will show you how to produce. Okay, now what we need to do? Now summarize the process. First of all, heat the triglyceride. Understand? Heat the triglyceride, add methanol and sodium hydroxide solution. After the reaction is complete, the problem is soap is forming. Then the composition is soap, biodiesel, glycerol, methanol, and sodium hydroxide unreacted. Then filtering, we can remove soaps and some part of sodium hydroxide. Then glycerol we can remove by separator by centrifugation. Then finally methanol we can remove by heating. Then finally 100% pure biodiesel we can get. Pure biodiesel we can get, that we called as B100 biodiesel. B100 biodiesel we can get after remove these all impurities. After remove these all impurities, we can get 100% purified biodiesel. I got that is a full biodiesel production process. Any doubt? I'll show you each and every steps. I will show you now. Okay, before that, take a paper and prepare a note, prepare a chart of steps of biodiesel production. Steps of biodiesel production. I'll show you all in a practical way. I complete the steps. First of all, heating, then add methanol and sodium hydroxide as catalyst. The methanol is raw material. Then mixing until the reaction is complete. After that, purification steps. Simple. That's a biodiesel. This is easy than soap production. Complete. Okay. Now I will show you how to produce biodiesels in actual way.
Using cooking oil, some fuel system cleaner, and a bit of lye. This diesel can be used in place of petroleum-based diesel fuel, but is completely sustainable and naturally sulfur-free. Now, to get started, I simply pour about 500 milliliters of olive oil in
Okay, see this.
biodiesel using cooking oil, some fuel system cleaner, and a bit of lye. This diesel can be used in place of petroleum-based diesel fuel, but is completely sustainable and naturally sulfur-free. Now, to get started, I simply pour about
This is used cooking oils. Used oil. By using used oil, that is triglyceride. If it is used, triglyceride is not damaged. The triglyceride, then we can use for biodiesel product.
about 500 milliliters of olive oil into a 1 liter beaker. Any oil will work here, but I accidentally bought gallons of olive oil during my soap making phase that I'd really like to get rid of. At this point, I turn on aggressive stirring and pour in about 100.
That's a styrene, okay, not whatever chemical. That's styrene. It is magnetic styrene. The name is magnetic styrene because of this instrument. It is located on the instrument. In this instrument, the magnet is rotating. Because of that, this one also the magnet rotating. See,
100 milliliters
It
of
is
the fuel
rotating.
additive. This specific fuel additive is nearly 100% methanol. And although methanol is preferred here, technically this process can be done using any alcohol with a minimal water content. Anyway, given that they're both fairly non-polar, the methanol will dissolve to some extent in the oil. They aren't entirely miscible though, so for the most part, this simply results in an emulsion of methanol and oil, which in my case turned out.
See the color difference become dark yellow color to light yellow color.
Light yellow. I next added 5 grams of sodium hydroxide, which represents a significant excess. This excess was used partially to drive the reaction to completion, but also to try and sequester any water that might be present. The beaker was then transferred to my hot plate and heated to around 80 degrees Celsius, at which point the reaction.
You can see that's a problem because of you adding sodium hydroxide for this as catalyst. Some part of catalyst is react with this triglyceride. Therefore, you can see like foam, like white color cottons. They are soaked. They are soaked.
Action became exothermic and heating was cut. At around 110 degrees Celsius, the temperature stopped climbing, and so at that point, heat was applied for the remainder of the reaction to maintain that temperature. Now, what's happening here is a two-step reaction that begins with a simple reaction between methanol and sodium hydroxide, forming sodium methoxide and water. The sodium methoxide then immediately begins to react with the oil in a type of reaction called a transesterification, which is very similar to the process used to make soap. Oils and fats are composed primarily of molecules called triglycerides, which are further composed of 3 fatty acids bound to glycerol. In this transesterification reaction, the sodium methoxide attacks the carbonyl here, forming an unstable tertiary intermediate. This intermediate then rearranges and subsequently collapses, displacing a methyl ester of the first fatty acid. In the final step, the glycerol backbone is protonated by the water molecule produced during the formation of the sodium methoxide, and the process repeats. This continues until all three fatty acids have been converted to their methyl esters, and the glycerol backbone is liberated as free glycerin. Since hydroxide is regenerated in the final step of the reaction, the sodium hydroxide essentially acts as an esterification catalyst. And this is why the 5 grams were a fairly large excess, and by using less, you might not need to go through the extra step of removing it later. As a side note, I came up with this procedure entirely on my own, and if I was going to do it again, there's one thing I might try differently. That is, instead of directly adding granulated sodium hydroxide, I might try dissolving the sodium hydroxide in the methanol first using a bit of heat, and then add that to the oil. I feel like doing it this way would help the reaction go to completion a lot.
Okay, that's a vacuum filter. Vacuum filter after this reaction complete. Now reaction is completed. You can see if there are any no change again and again with a few minutes, the reaction is completed. Then we can get the solution, and first we filter by vacuum filter. Why? To remove to remove solid sodium hydroxide, because we add the solid sodium hydroxide, no, but some part can be dissolved. I will explain how to remove this. The solid sodium hydroxide first we remove by the catalyst. We remove the contain as a solid. We remove by filtering of the solid sodium hydroxide. Here you can see, as we discussed in the lesson.
Faster, but it might result in an ultrafine precipitate of
That is vacuum filter. Okay.
Which could be more difficult to remove than the granules.
That's the vacuum.
Anyway, as the reaction proceeds, the mixture becomes increasingly dark and eventually clears up. A lot of little bubbles are produced early.
Do you remember in recrystallization we discussed about vacuum filter? Yeah, this also same. The recrystallization, that's a vacuum filter.
Which I suspect is due to unreacted methanol trying to evaporate. After about
You can
30
see
minutes
this
of
foam.
reacting, I felt nothing more was happening. And so I took the beaker off the heat and passed the crude biodiesel through my Buchner funnel to remove all of the excess hydroxide. This was then transferred to a separatory funnel.
This is the Buchner funnel or separatory funnel. That's a Buchner funnel. You can see every equipment. You can see this is a shape. You can see how to separate by using this.
At which point I left it overnight to allow the more
you can see this is glycerol
to settle
this
to the
is
bottom.
biodiesel.
When I came back the next day, my plan was to drain away the.
We only need to keep few minutes. The glycerol and glycerol and biodiesel easily separate because they are polar and non-polar solvent. Easily separate. You can see the color difference.
The glycerol layer so that I could begin the process of cleaning up the crude biodiesel.
In removing the
Unfortunately,
glycerin,
I quickly found that the glycerol had solidified, and that wasn't going to happen. I suspect this is mostly due to the fact that the glycerol layer likely contains all of the water-insoluble impurities that were in the oil. It's also probably due to the glycerol forming soap with any water that was hanging around and some unreacted triglycerides.
This is
regardless, I went ahead and just decanted off my crude biodiesel layer and rinsed the glycerol soap mess out of my separatory funnel. Once it was nice and clean, I returned the biodiesel to the separatory funnel along with 400 milliliters of water.
That's why I told you some part of sodium hydroxide we added as catalyst can be dissolved with this solution. If they are present, the quality of biodiesel is not 100%. Therefore, we need to add water. When we adding water, the biodiesel and water is not mixing. Therefore, non-polar and polar, that's not mixing. But if when we add water, when we shake well, the contained sodium hydroxide, if there are any small amount of short sodium hydroxide that dissolved in water, then with this water layer we can remove, because water is higher density than biodiesel. Therefore, easily we can separate. See.
I gave this a vigorous shake and allowed the aqueous layer to settle to the bottom. This step will help wash away any soaps or unreacted hydroxide from the biodiesel. There shouldn't really be any unreacted oil present, as any fatty acids that didn't convert to biodiesel simply became part of the soap. Anyway, the rinsing step is repeated 2 more times until the aqueous layer is completely clear and the layers separate very quickly due to removal of any surfactant molecules. The biodiesel is next drained into a flask, and at this point, the only significant impurity is water. The water can obviously be removed by boiling, but because I felt that was unnecessarily dangerous, I instead dumped in a few grams of anhydrous sodium sulfate and gave the flask a hard shake. This was again left overnight, during which time the sodium sulfate completely absorbed any water that was present in the biodiesel. This was then passed through my Buchner funnel one final time, leaving me with a pure and dry biodiesel. I forgot to weigh my final yield, but as you can see here, I produced just enough to perfectly fill up this 16-ounce mason jar. Now, here I have 3 test tubes.
Yeah, this is the
first
biodiesel.
contains unprocessed olive oil.
Purified
the second
biodiesel.
contains a sample of my undried and
That's
unfiltered
the
biodiesel.
purified biodiesel. Color, see the color? It's same as olive oil. The color is same as olive oil. It's a comparison that you don't need. You just only understand the steps, and just in the biodiesel production, the it is easy. Then what we need to do, heat and react the raw material methanol and sodium hydroxide as catalyst. Then the reaction is happening, but there are a lot of impurities. By different method we can remove these impurities for each step. Within each step we can remove one by one raw impurity. Then we can get the finally 100% pure biodiesel. Understood? Any doubt in biodiesel production? Biodiesel production 2 to 3 point we have discussed. More I will do in next week. Up to this level, can you complete within this week? Within this week you have to complete entire soap production steps, process, and you have homework how to produce detergent and liquid soaps, and how you need to complete up to biodiesel production process. Any doubt about biodiesel production? No? Any doubt? Okay. Try to understand, and I will give you summary. No, not like paper discussion. The lesson discussions difficult than paper discussion. No, up to 11. Okay, okay. I know it's not easy. 6:30 to 11 p.m. It's not easy, but we have to do this way because we have very limited time. Okay, then try to understand the process. I hope you got the each point of that. Then you can prepare a short note. So production, biodiesel production, prepare short note before next week. Then you can understand every steps process. Then I will give you full summary of the biodiesel production again at the first part of the next day. Then I will complete within next day. We complete the paint production, fertilizer production, and paper productions. Then the lesson is complete. Tomorrow you have, I will inform you, tomorrow you have work, energy and power, two parts. Therefore, if it is 4 a day, you don't have, you can't get any break. You have to work. Okay. Any doubt from today part? Any doubt? I got the production process, biodiesel, and I got. Okay, now better to prepare within tomorrow. If you can today, you have to prepare the short note of this biodiesel production and soap production. Otherwise, they will forget. Okay, therefore, don't get time. Prepare your short note within short time. Then today we discuss things. Within tomorrow, you can remember again. Then you can prepare a proper short note of the soap production and biodiesel production. Then the other three industries are easy. Paper production, they are easy. Okay, that's all for today. Good night.